this, I had a really interesting conversation about policy and climate change with my seniors. We didn't have time to fix the desks. So, similar to what we did in class on Friday, I want to extend on that during class today. Now, before we do that, ladies, thanks. Before we go through or forward with this, first I want to make sure that we're reminded about what the processes we're going through and why. The last important thing that we really need to touch on for this semester exam is your familiarity with nutrient cycles. And there are a lot of nutrient cycles that we could go into, but the IB guide specifically outlines this conversation about both carbon and nitrogen cycle. You should have experienced some familiarity with this before you came to my class, and I actually dove into some of this earlier on in the school year. Now, as I've reflected on this, and I will approach it differently in the future, I think you all are actually at an advantage than grade levels previously, because some of you chose to tackle this nitrogen cycle diagram on your own previously. Now, if you want to see what a key to the nitrogen cycle should look like, this is a screen capture from your textbook for this actual course. Now, some of you came up with some stuff even more elaborate than this, which I'm happy with. But what's important for you to also understand is not just what boxes are connected by what arrows, what do those words actually mean? Like, for example, nitrification is worthy of an entire week worth of this class. I don't have a week to give you, but I could ask you to be familiar with what it means to nitrify or denitrify something. Because while this is not plant physiology and this is not agronomy 101, we get to that later on in the school year and early next year. But for you, understanding what each one of these words are and how they fit together in a system is what's important. Because once you understand the pieces to the puzzle, then you can start to say, which part of that diagram do humans have the most impact on? Because that's the nature of this class. Equal parts science and mixed with human choice and human impacts and how can we do it better. So, with that being stated, this is a general systems diagram that I have shown you here at the beginning of class. But for my students, I think it's important for you to develop a vocabulary with a more hands-on experience, which is why, as we did in class on Friday, with the carbon cycle, I feel as though simulations are a great way to do this. YouTube videos, a great way to do this. Book chapters, great way to do this. And the lovely part about you all being required to have technology with you at all times at school is that you have access to all of those things right now. So, with this diagram as a precursor to it, your assignment in class today is almost the exact same as it was in your class period on Friday, except this time we're focused on the nitrogen cycle. So, I'm going to go through this instruction set with you and make it very clear about what you need to do in class today and what you'll be using it for during your class period tomorrow. Near the top of Google Classroom, you'll find the links to both of these simulations that are available to you. The one that we're focused on today is the nitrogen cycle. Now, if you've already got this open, great. If you don't, it doesn't technically matter. But I want to point out some key components to it that you should be reminded about or introduced to in your attendance in class. Now, as it loads, remember, your imagination might be required here a little bit because these particular cycles are meant to make you think in more than one direction. For example, feeding relationships before you arrive to ESS moved in one direction. So Thea is eaten by Isa is eaten by Mika, Steffi eats Mika, and then we've got a singular line. There's one-to-one relationship. But does that actually happen in real life? No. Just like in these nutrient cycles, it is not a perfect circle. And an independent nitrogen atom could venture in a lot of different directions. The important thing for you to understand is less about how to draw stuff and more how those things relate to one another and why they're connected. This simulation is meant to do this. So you're going to visit another 12 total stations. Now, some of you really dove into this and I think did quite a good job. Others of you had some room for growth based off my observations in class on Friday. So I'm going to tell you what you do in class once more today and what you're going to do in class tomorrow so that I can give you a grade for it. This grade is meant to be easy if you actually do something in class. Now, after you visit a total of 12 stations, you will have populated a table that you created for yourself that again has 3 columns. Each one of you should do this individually. And I advise that you do it either by one, making a copy of this presentation for yourself and inserting it in there, or just drop a table into your online, ongoing digital notebook for this class so that you have it available to you. Those columns should be like the starting reservoir, a flux mechanism, and a resulting reservoir. As is stated in the second piece of instruction here on line 2, at the number 1, you pick a reservoir, and it doesn't matter where you start. Because at any point, a nitrogen atom could take a different adventure to be in a different form in a different place. Your job is to be able to describe how that happens through different flux mechanisms. So if you want this to work as a math equation, if you start somewhere and then you have a transformation or a translocation, you end up in a different reservoir. Your reservoir in this column and row right here will ultimately become your starting reservoir for the next line. And we use a random number generator, whether you choose the dice application or you just randomly select numbers. I actually really don't care. But using a random number generator that has a maximum of 6 options allows you to truly take a random path through this. Now, many of you pointed out for the carbon exercise, well, I just stayed a rock for like 8 of my pieces of dice rolls. Does that make sense? Yes. Because how long does it take for a rock to stop being a rock? A really, really, really long time. Millions, hundreds of millions of years. So does that make sense to you? Yes. A significant portion of the world's carbon isn't in the atmosphere. It's actually like a minuscule percentage. But because of its power to create change, the amount that we are putting into the atmosphere in addition to what's there naturally is a problem. Nitrogen can be viewed in the same light. So once you create yourself a table and you start to take a journey through this, your destinations will determine your journey. And for you to completely be able to do this and to help you out, here's your actual definitions. Friday, I asked you to define it yourself, but some of you either just got lost and chose not to do it or spent more time copy-pasting definitions and actually going on a journey. There's the vocabulary for you. Okay, this time I want you to focus more on how these flux mechanisms connect to different storages without having to describe each one of those terms on your own. Now, on a semester exam, for example, I would not be giving you a list of what those terms mean. I would expect you to know what precipitation means. If you didn't know already, it's there for you. And remember, I use the term flux mechanism because sometimes things can be physical in their change, like transforming into one form or another. Other times it can just be relocated in the same form. Regardless of whether it's transforming or transferring, the difference is it is going from one storage to a different one in a state of flux. So for you, these terms help you fill out the flux mechanism portion, the center column in this conversation. You choose your starting reservoir, and the random number generator helps you venture through this. Now, at the end of this class, whether you work on this collaboratively and go through a couple of simulations yourself, or you just work independently is cool with me, but you are responsible for having one of these charts filled out for yourself by the end of class, and here's why. When you come to class, I believe tomorrow, yes, tomorrow for you guys, I'm giving you an assignment. I'm going to ask you to read a certain portion of a book that is about 3 paragraphs long. I'll give you some resources that are available online. But your assignment is 1, take the completed table that you created for yourself, either in class today or on Friday. 2, comment on the 3 places that you think humans have the most impact based off of prior knowledge and resources that you have available to you in class tomorrow. And 3, draw a systems diagram of your individual journey through that system. Now, it might involve you going to 3 different storages. It might involve 8 different ones, but that's the nature of this. I give you a completed version of what the nitrogen cycle is. You give me your example in a systems diagram, and this is wonderful for me because, number 1, systems diagrams and analysis is probably the most important thing we've talked about so far this year in terms of what's on your semester exam. Number 2, it forces you to focus on your ability to understand how terms connect together instead of regurgitating information that you memorized the night before you took my exam. This makes for excellent assessment questions moving forward and gives you an opportunity to take a lot of moving parts and stick them together. So if you feel like you didn't do your best work on Friday, that's cool because you can use the more complicated system to do your assignment in class tomorrow. If you feel like you did a really great job on Friday, by all means, use the carbon cycle to do the same thing. So in your class period today, first thing you're doing is what? It's written on the board. It's written on the board. Yep. In total, you're going to visit 12 stations. In the process of doing a visit to those 12 different stations, which are randomly chosen for you, all you have to do is click. What do you fill out in the process? This chart that's even showed for an example of how it should ultimately look. Now, if you make it different colors, cool with me. If you do it as an Excel spreadsheet, fine by me as well. Your process by which you document the journey that you take is not important. Your understanding is. Now, after you've visited total 12 stations and you've been able to fill all these things out, if you finish this early, you have the option to do it again. You have the ability to help your classmates out and to make sure that everyone's on the same playing field as we move into the review portion of this week. And I would also encourage my students to make sure you have a detailed understanding about what those flux mechanisms are, because really, I understand that things such as precipitation and infiltration are directly related to one another. More precipitation means more available water. If it's not infiltrating, it's surface runoff. If you want to understand how the water cycle and the nitrogen cycle start to cross over, water is the key player in every one of these things you'll ultimately talk about. We'll get to the water cycle towards the end of this year, at which time we'll do something very similar to this once again. My hope is that your view of systems and nutrient and material cycles within the Earth system itself are enhanced by you understanding not only what vocabulary words mean and what systems diagrams are, but how you create them at the same time. So what I ask for you to do is either collaboratively or individually run through this series of simulations by beginning at the choice of a starting point in the cycle simply by clicking. Fill the chart out the same way that you did previously, and at the end of class, if you have any questions that I haven't answered for you previously, feel free to stand here and talk to me about it during recess, because I'm trying to give you an easy grade on this tomorrow. Any questions? Okay, go for it. Box you into the champion, kicking my students into gear. While from under vacation from school, I think you should focus some of that vital energy into nitrogen cycle. Cycle some of that nitrogen and carbon into learning instead of conflict. Okay. I'll keep your medal warm for you. Yes. I'm the champion of science.